Alrighty, so here is your key to the review. It says, using proper vocabulary, describe the transformation of each parent. So p of x equals negative square root of x. So this is the square root function. This negative out inside of it is a change of y, not a change of x. So if we're going to change the sign on y, then this is a reflection across the x-axis. Okay, changing y is going to reflect it across the x-axis. All right, so then this is 1 over 2x, so this is a change for my x. Remember when you're doing x that you actually do the opposite of what you see, so instead of multiplying by 2, we are going to multiply by the reciprocal, which is 1/2. So with x, this makes this a horizontal change. It's a horizontal, and since I'm going to be multiplying the x values by 1/2, that is a compression by factor of 1/2. Okay. And here, absolute value function, we are changing the x, so we do the opposite. So instead of adding 2, we're going to subtract 2. So this is a horizontal shift. And then since we're subtracting 2, this is going to be left 2. Okay, so this is our quadratic, and I'm changing x here. So a change of x is going to be a horizontal something, right? Horizontal. And then since we're multiplying, it's either going to be a stretch or a compression. When you multiply by x, or you multiply something times x, then you are going to do the opposite. Instead of multiplying by 1/3, we multiply by the reciprocal, which is 3, which makes this a stretch. So it's a horizontal stretch by a factor of 3. Okay, so this is the inverse square, and we are doing a change of the x, so that makes this a horizontal. Okay, when you add or subtract, that makes it a shift. And then since this is x minus 4, we do the opposite, so we're going to add 4, which means we're shifting to the right. And it would be 4. Okay. So here, quadratic again, and this is a change of the x. So when you change the sign on x, that is a reflection in the y-axis. Okay. So this is not the absolute value parent function. This is a cubic. All right, so we have to remember our rules for the absolute value transformation. So your cubic looks like this. Right? So the rule for your absolute value is that you're going to throw away everything where x is less than 0. So all of this over here just goes away. So this will go away here, disappears. And then you take what's left on the right-hand side and you reflect it. Oops, that is not the shape I wanted. Can't do it backwards, I gotta do it this way. Reflect it over here. So it looks like that, but a whole lot better. So the transformation that is happening is that you throw away points where x is less than 0. Then you reflect, spell it right, reflect points where x is greater than or equal to 0. I should have done that differently. Where, where x is greater than or equal to 0, that way, across y-axis. All right, so then this is the cube root function. Okay, I'm not doing the change on x, so this is actually the change of y. So when you change y, you do what you see. And since we're multiplying and it's y, this is vertical. Okay, and it's either a stretch or a compression. When you're multiplying by 4, we're not doing the opposite here, so this is a vertical stretch by a factor of 4. Okay, next one. Given the point negative 6, 9 on the function g of x, write the new point for the following transformations of g of x. All right, so just change the sign on x, which means this is just going to be 6, 9. This is g of x plus 3. I'm changing the x, so I do the opposite. The y stays the same. It's just 9, but I'm going to subtract 3 from negative 6, so that's negative 9. Okay, 4 times g of x. This is a change for the y, so the x stays the same. It's negative 6. And I'm just going to, when you change y, you do what you see in the order of operations. There's only one thing, so 4 times the y value is going to give me 36. Okay. G of x minus 2, this is going to be a change just for y, so the x value is still negative 6. And it's y, so I do what I see, which is minus 2, so 9 minus 2 is 7. All right, so then this is negative g of 6x. So the negative part is on the y, so when you change the sign on y, that's a reflection. So all that's happening to y is I'm changing the sign. That becomes negative 9. This is a change for x, so that means I do the opposite of what I see. So instead of multiplying by 6, I'm going to multiply by 1/6, which is the same as dividing by 6. So negative 6 times 1/6, or negative 6 divided by 6, gives me a negative 1. Here I'm changing x and y. So for the x part, I do the opposite. Instead of subtracting 8, I actually add 8, so that's going to give me a positive 2. And for the y, I'm going to subtract 5, and that gives me 4. Okay, now I'm going to graph each parent function transformation. So remember, you should be able to do this visually and graphically and understand what is happening from a table. You also need to know what the parent function looks like before you ever even start. So if it's not good enough just to kind of have it in your head, not a bad idea just to jot down what's happening here. So something like that, and think about where your key points would be. Something like that, but better. Always better. So you need to know what's happening. That's why the questions above are helpful here. I'm changing the sign on x, so when that happens, it is a reflection in the y-axis. So I know it's going to, instead of coming up and being like this, it's going to come up and be like that. And then I'm also going to shift it down to. So instead of being here at 0, 0, because whether I'm here or reflect over, I still have that point. So I probably shouldn't have actually plotted, but okay. So instead of being at 0, 0, it's going to go down to. Okay. I would have had, for the square root function, I would have had a 1, 1. That becomes negative 1, 1 when I reflect, and then I go down to, there's this one. Would have gone to 4, 2. So that would make that negative 4, 2. And then I come down to here, so it looks something like this. You want to think of it from a table perspective. I won't necessarily do them all 3 ways, but or both ways. So my original key points here for a square root would be 0, 1, and 4. Right? So that would give me 0, 0, 1, 1, and 4, 2. But then when I do this transformation, this actually becomes opposite of x, and this becomes y minus 2 from here. So this is 0, negative 1, 4. And then this becomes 0 minus 2, which is negative 2. 1 minus 2, which is negative 1. 2 minus 2, which is 0. And you can see that's the points that we have here. 0, negative 2, negative 1, negative 1. -4, 0. So however you come up with them, just make sure that you know if you need to do the table first and then the graph, or the graph then the table, you need to be able to get to it in some form or fashion and be able to answer both. Okay? All right, so this next one, this is a cubic. All right, so parent function for my cubic looks something like that. Okay. And so what's happening here is this is a reflection, and that would be changing the sign on y, which means it's a reflection in the x-axis. So that would flip it around like this. And then I'm also going to do a horizontal shift to the right 1. So I'm here at 0, 0, and go to the right 1 of this point here. And then instead of the curve coming like this, it has reflected, so it's going to come in like this. If you don't know what your key points are and what you need to do with them, make yourself a little table. But if I had the original one, 1, 1 would have been 1. So all that happened was that I made that -1, 1, and then I moved it over. So there's that. And then here's the other one. But remember, this is not linear, it's cubic. So the other one I would have had would have been 2, 8. But I reflected it, so it became -2, 8. And then I moved it to the right 1. So I'm here. So then also it would be down here. Okay, you can get your shape graph. You need some key points and make sure that it looks semi-decent. And then you can just pull the points off the graph if you needed them for what you need. Okay, 17. So this is the inverse square. So your inverse square function looks something like this. And so I have two asymptotes here. I need to take that into account when I'm doing what I'm doing. I've got two things going on here. I'm going to reflect it in the x-axis. So it would come and end up looking like this. And then I am also shifting it to the left one. So I have two asymptotes here. It's x equals 0, and y equals 0. And since there's not a vertical shift of any sort, then the line y equals 0 is still an asymptote. So if I draw those in, so this is still an asymptote, but the one that was x equals 0 is going to get shifted to the left, so it's here. So when you have asymptotes, especially when they were the axes to begin with, now when you redraw it, you can just pretend like that's still the axis. And so when you have the parent function, in the parent function, 1, 1 is a key point. So if I pretend like these are the axes, here's another key point there, except it's not there anymore because we reflected it. So instead of being at 1, 1, it would be down here. And then I also have this one. Okay, so again, pretending like these are the axes. Remember, it has reflected down because of the negative. Then another key point I would have had would have been 1/2, 4. So I go to 1/2, and then, well, 1/2 when I look at these as the axes, and 1, 2, 3, 4. And then 1, 2, 3, 4. Right there. 1, 2, 3, 4. And 1, 2, 3, 4. You've got to be able to know that I can see and figure out where your key points were. Making yourself a T-table may be the way that you want to go, or plotting the original one may be better than that so you know how to count and where to go. Just make sure that you can get all the pertinent information out of it. All right, so this one here is the square root. No, it's not. It is the absolute value function. That's what I meant to say. So my parent function looks like this. So that negative, that is a negative x. what it's changing. So that's going to be a reflection in the y-axis, which is very uneventful because then it still looks like this. And then this is a horizontal compression by a factor of 1/3. So 0, 0 is still a point. And then if you're going to multiply each x value by 1/3, so maybe we go to what used to be, we'd go to 1, 1, 2, 2, 3, 3. I'd be here at 3, 3. But that 3, that is the x value, is now multiplied by 1/3, so it's actually right here. So it's this one. Okay, and then the 6, 2, 4, 6, which will be at 6, 6, 2, 4, 6. But I take that 6 and it's multiplied by 1/3, it becomes 2. So I'm right here, and here's what this looks like. Oh, that's straight. It might be safer for you. It just depends. I mean, it's kind of personal preference how comfortable you are with all these. I mean, they are a review. If you set make yourself a table, because it doesn't have to be difficult for you to need a table to wrap your mind around it. And if you have, if you know that you're going to multiply by a factor of 1/3, then having x values that are multiples of 3 could be very, very helpful. So if we did start with the -6, -3, 0, 3, and 6. Okay, so when it's just the parent function here, because this goes with the parent function, then this is just going to be -6, 6, -3, 3, 0, 3, and 6. And then you can see when you come in and actually multiply that by the 1/3, that just changes that to the 2, that to the 1, 0. 1 and 2. Okay, so if that's easier for you to see the points and know what that is instead of just trying to keep them in your head, whatever works, but you got to have some key points there. All right, 19. So square root function. All right, your key points for the square root function. 0, 1, 4. 9 is not a bad idea. It's going to give me 0, 1, and 2. Right, so that's what's happening here. Now, we're going to have to do transformations on this. So this 0.5, which is really like 1/2, it's being multiplied by x, so I do the opposite. So instead of multiplying by 1/2, I multiply by 2. So I'm going to double all of my x values, and I'm going to add 3 to my y values. So when I do that, this actually becomes, we'll do this. This is 2x and y plus 3 is what I'm looking at here. So this is 0, 2, 8, and 0, 4, 5. So I still have 0, 0. Now I'm at 2, 4, and I'm at 8, 5. Here's what's happening with that. Oops, I missed 3. Let's make it bigger. All right, so this here is not a square root function. This is a semicircle because I have this here. This is my a squared minus x squared. Remember that a squared is the number, so a is 4, and that means that's the radius is 4. So when you have your parent function, and that's what it looks like to begin with, this is -4, 4, and 4 here. Okay, so I am not changing x at all, so my x values stay the same, but I am going to double all the y values because I do what I see, so it's times 2, so I have -4, 0 is still a point. 4, 0 is still a point. But instead of 0, 4, it is now 0, 8. 2, 4, 6, 8. And then I curve it to the best of my abilities. Like so, but better. Always better. it shouldn't go out like that. I could do it better on a piece of paper. It's hard to do that on the board.